is given that A, B, C belongs to empty and R such that A equals to BC, then which of the following statement holds? Okay, so the thing is that claimed column space of A is contained in column space of B. So column space of any matrix is basically a span of columns of A, which is same as image of A. Why this is true? If you can take, say, 2 by 2 matrix in particular for an easy example, then what will you have? It will have Ax plus By, Cx plus Dy, which is same as x into A comma B plus y into x into A comma C plus y into B comma D. That means this vector is in span of A comma C and B comma D, right? So that means column space is basically same as image of A. Okay, that means say y equal to Ax for some A. This will imply that it is BCX. This will imply it is BW, where Cx equal to W. That means y belongs to image of B. So y belongs to image of A implies y belongs to image of B. Then column space of A is contained in column space of B. Now for row space, we can do the same thing, but we can use a trick. A equal to BC, right? Put A transpose, then it becomes BC transpose, which is same as C transpose B transpose. Now column space of A transpose is same as row space of A. Then by similar argument, column space of A transpose is contained in column space of C transpose, which is implied row space of A contained in row space of C. And this is also true. Now most of the students have doubt that why option A and D are false. Okay, so in particular, since it is given for M10 matrix, so 10 by 10 matrix taken and giving counter example is really lengthy. So in particular, you can give a counter example for 2 by 2 matrix. Okay, so let's choose C equal to 0 0 1 1, B equal to say 0 1 1 0, and what will you have? A equal to 0 1 1 0 times 0 0 1, which is same as 1 1 0 0, right? Now say Ax equal to 1 1 0 0 times xy, which is same as x plus y 0 star. And if we see, you see row space of B, what will you have? Sorry, column space of A, and if you see column space of C, so okay, so yeah, sorry, I'm a little confused. Yeah, so what about column space of C? Column space of C means say Cx equal to 0 0 0 0 x y, just have 0 x plus y. So clearly column space of A doesn't contain the column space of C. In particular, you can take this transpose and counter, you can keep counting simple for it. So hence A, D are false. Given answer in the answer key is correct actually. So those who have a doubt, you can check this counter again. Okay. I hope it will be clear and BCL correct. So in particular, the idea is that column space is actually same as the image. Okay. So and the row space is basically same as the column space of transpose. So when you are taking the transpose of the product, it becomes different. Like AB transpose is basically B transpose times A transpose. So that's why it becomes there is a change here. Okay. So that's why BC are correct but AD are false. Okay. Now come to the next one. There is another one problem which you have done. This is actually a proper issue. If I want to give the proper solution, it takes time. Okay. So let xn plus 1 plus 2 same as minus xn square plus 4xn. That means xn plus 1 minus xn is minus xn square plus 3xn minus 2, which is same as xn square minus 3xn plus 2, which is same as minus xn minus 1 xn minus 2. Number 1 relation. Okay. Now I'm doing for option A. Let alpha belongs to 0, 1. Okay. Let alpha belongs to 0, 1. Then alpha minus 1 times alpha minus 2 is less than 0, sorry, minus alpha minus 1 times alpha minus 2 is less than 0, obviously, because this one is negative, this one is negative. So in particular, the product is positive, but since we are taking negative sign, so that means this is definitely less than 0. Right? This is definitely less than 0. That means xn plus 1 is less than xn. This will imply xn is monotonically decreasing. Okay, so before going to that, we need to check one thing that will be easier for us. So if possible, limit exists. Okay, then what will be the value of limit? That means limit n tends to infinity xn equal to L. That will imply that L square minus 3L plus 2 equal to 0. That means L equal to 1 or L equal to 2. So since xn is monotonically decreasing and x1 is alpha which lies between 0 and 1, that means xn is always less than 1 value, right? So that means it doesn't converge to 1, okay, and it is monotonically decreasing. So option A is false clearly. That is the case. Now from B, C, D, we need to be careful, and given answer is actually correct, so I'm going to prove it carefully. Okay. Okay. So we have xn plus 1 plus 2 is basically xn times 4 minus xn. So consider a function fx equal to 4x minus x square. Then f prime x equal to 4 minus 2x. Now if x belongs to 1, 2, that means f dash x is greater or equal to 0. That means f is increasing. Hence, in particular, f of 1 is less than f of 2. Okay, and all the values lies between these. So, if I take, what should I take? So that means xn 4 minus xn, that belongs to, if I put xn equal to 1, 3 comma, if I put xn equal to 2, 3 comma 4. Okay, if I put xn equal to 1, it is 3, if I put xn equal to 2, that is 4. And it is increasing, right? This is increasing. Okay, that means sorry, it is x1, I'm talking about x1 now. That means x2 plus 2 belongs to 3 comma 4. If x2 belongs to 1 comma 2. Okay, that means x2 belongs to 1 comma 2. So since we have already solved alpha equal to, alpha lies between 1 comma 2, we have x2 belongs to 1 comma 2. Okay, then recursively we can do the same thing. Okay, and now if we choose this thing, we can see that xn plus 1 minus xn, that is greater or equal to 0. Okay, I mean, in particular, if we choose alpha greater than 1 and okay, alpha greater than 1 and less than 2, that means this product is less than 0. This product becomes less than 0. Since that is minus, so this product is actually greater than 0. So xn is monotonically increasing here. So here we put something. So here xn is monotonically increasing. Okay, xn is monotonically increasing, and we have already shown that xn belongs to, recursively we can show that xn belongs to 1 comma 2, because we are assuming that alpha belongs to 1 comma 2, and then we have shown that x2 belongs to 1 comma 2. Then instead of alpha we can put x2 and get idea of x3. Then x3 belongs to 1 comma 2 and so on. That means xn is bounded above by 2. Since by Norton convergence theorem xn converges to 2. Hence B option is correct. Come to the part option C. Okay, so again we have already done. So option C, fx is given by the same thing, 4x minus x squared. So f prime x is 4 minus 2x. Now there is this issue. When alpha belongs to 2 comma 3, that will imply that f dash alpha, sorry, x belongs to 2 comma 3, that will imply f dash x belongs to minus 2 comma 0. That means f dash x is less equal to 0. That means on this interval f is, that means on 2 comma 3, f is monotonically decreasing, right? Now what about f of 3? F of 3 is basically r1. F of 3 is basically 12 minus 9, which is 3, and f of 2 is basically 8 minus, that is 4. It is 4. Okay, that means the product alpha into alpha minus 4, alpha into alpha minus 4, that lies between 3 and 4. That means 3 less than x2 plus 2 less than 4. That means 1 less than x2 less than 2. Then we will have the same thing we have already done. Okay, from the now we can apply R to B. to argue that xn also, xn is CDT and xn common raised to 2. Okay, so hence option C is also correct. Also correct. Now option D. Again choose the same function fx equal to 4x minus x square, f prime x equal to 4 minus 2x. Now for x belongs to 3 comma 4, from x belongs to 3 comma 4, f dash x belongs to minus 2 comma, sorry, f dash belongs to minus 4 comma minus 2. That means f dash x is less equal to 0. That means f is monotonically decreasing. F is monotonically decreasing on this interval. Right? Then let's say f of 3. F of 3 is 12 minus 3 square. That means 3. F of 4, 16 minus 4 square. That is 0. Right? So that means what? And since we can't attain exactly 4, that means we have a value that, okay, that means what we can say, that means our x2 plus 2 lies between 0 and 3. That means minus 2 less than x2 less than 1. Again, by part 1, x2 less than 1 means x3 less than x2 less than 1 and so on. That will imply xn is divergent. So it is not so obvious that why this you can't directly solve it. So you need to manipulate and check that what is going on. So part A and B, if you can do part A and B, and if you can properly do C and D, you can see that C is actually application of D after first iteration and D is application of A after first iteration. Hence xn is DGT in this case. So given answer is actually correct. You don't need to challenge. So BC correct.